Okay, here's our final section of 1-2, solving with exponents. And here is where I feel like we're going to take everything and just really put it together. So, example 1 says 12 equals 5x squared minus 113. How are we going to solve something like this? Well, I'm going to write PEMDAS off to the side. We're going to bring this back from our very first lesson with our arrow going up. And let's note, what things do we see on the right-hand side with our variable x? We see the multiplication by 5, we see the 2, or the exponent, and we see the subtraction from that minus 113. And remember, we're going to start at the bottom and we're going to work our way up. So the first thing we have starred is the subtraction. And you ask yourself, how do I get rid of subtraction? What is the inverse of that operation? So of course we are going to add 113. Now once again, when these get more complicated, students get confused. Draw this little wall through your equal sign so you know if we add 113 to the right, we have to add 113 to the left. And so 12 plus 113 will give us 125 is equal to 5x squared. Now from here, after our subtraction, we move on up to the next thing we have starred, which is our multiplication. And how do you get rid of multiplication? How do you get rid of that 5? Well, we divide both sides by 5, and that reduces to 1, kind of like we talked about with our multiplicative inverse. And so we have 1x squared is equal to, and look, if you have to use your calculator, go to it. 125 divided by 5 is 25. Now from here, this is kind of where we're getting into Algebra 2, like when we start adding these exponents. How do you get rid of a square? Well, remember, back to our last video, the inverse of a square is a square, what's that word? It's a square root. Awesome job. And so the inverses of a square, we take the square root, they cancel, and of course what we do to the right, we have to do to the left. I included a link to the Desmos calculator at the top of this practice section. You can go click that if you need to. But the square root of 25 is in fact 5. Okay, let's go ahead and move on to our second example. As always, I would encourage you to pause this and finish taking your notes. Okay, example 2. Man, we're going to be really good at these by the time we are done. We have 6 minus 2x cubed is equal to 22. Now this is going to be the last time that I use our PEMDAS mnemonic for this video, but let's be very diligent here. And so we look on the left hand side and we see that there's a plus 6, so we have addition. We see that there's a negative 2 being multiplied by the x cubed, so there's multiplication. And of course we have that 3, our exponent. So we start at the bottom, we're working our way up, and the first thing we have starred is the addition. Now how do we get rid of a plus 6? Well, minus 6, and of course that zeroes out. We have negative 2x cubed is equal to, and 22 minus 6 will give us 16. Now from here, we continue on up, and the next thing we have starred is our multiplication. And what is the opposite of multiplication? Well, it's division. We divide both sides by this negative 2, it reduces to 1, and we're left with x cubed is equal to negative 8. Now from here, we are now to our exponent. And what is the inverse of cubing something? Think back to our last lesson. We're going to take the cube, what? The cube root. Yes, exactly. It's always going to be the same word. The inverse of a square is a square root. The inverse of a cube is a cube root. The inverse of the fourth power is the fourth root. It should get pretty easy here soon. And so we take the cube root of both sides. Once again, I encourage you, use your calculator, and you'll find that the cube root of negative 8 is negative 2. Okay? Pause it, finish taking the notes. Oh, and by the way, what would this kind of look like? Well, it's actually got a negative in front. I haven't really discussed that, but it means that our our graph is somewhat flipped, so it kind of looks like that. And we're saying, hey, when x is negative 2, we're saying that this is going to be at a height of 22. Okay, so you see that 22 right there, you see that negative 2. That's essentially what's going on here. All right, let's go ahead and move on to our third example. Okay, example 3. Now let's even use different letters here. Let's say this. Let's say we have 44 is equal to 6 square roots of b plus 20. Now I'm going to solve this for the letter b exactly like I want you to solve it when you feel proficient in the math. So what would that look like? Well, I'd look here. I would say I got to get rid of my addition first. So I subtract 20 from both sides. 44 minus 20 is 24. Oh, 24 here. Let's make that nice and neat. Let's not be lazy. 24 is equal to 6 square roots of b. I would then say I get rid of that 6 by dividing both sides by 6. 24 divided by 6 is 4, is equal to the square root of b. And look, if the inverse of a square is a square root, then kind of working backwards, the inverse of a square root is a square. And so we square both sides. Now the square and the square root cancel, and we have b equals 4 squared, which is 16. All right, we've got one final example. Oh, and by the way, what would this look like? Well, a square root, it's always going to look something kind of similar like that. And all we're saying, this is kind of a rough sketch. We're just saying like, hey, if our b was our x value and this was 16, we would simply be saying, hey, this is going up to a height of 44. So I just want you to understand we are solving for a specific point on a much more broad function. Okay, let's move on to our last example. All right, here we go. Here is example 4. And for example 4, we have 118 is equal to 1/3 cube roots x plus 112. Now you might see these large numbers, you might feel concerned. Don't worry, you have your calculator, all right? Desmos Scientific Calculator. No stress. From here, we get rid of our addition first. Minus 112, minus 112. 118 minus 112 gives us 6 is equal to 1/3 cube roots of x. And of course, how do you get rid of a fraction when it is the coefficient? Well, we multiply by its multiplicative inverse. Remember, we flip it, and so the flip of 1/3 is 3/1, and those reduce away. Now what we do to the right, we have to do to the left, and recall 3/1 is the same as 3. So 3 times 6 will of course give us 18, and we get 18 is equal to the cube root of x, and from here we now have to cube both sides. So I raise this to the power of 3, I raise this to the power of 3, and I might have made a slight error. I actually don't know myself what 18 cubed is off the top of my head. So let me grab a calculator, type in 18, raise it up to the power of 3. Oh, big number. 18 cubed will give us 5,832. And that's one thing you have to be careful of whenever you're dealing with a cube or any power higher than that. It makes small numbers incredibly large very, very quickly. All right, I hope this helps. Oh yeah, one last thing, let me just show you kind of what this looks like. So a cube root will always look something like that. And what we're essentially saying is that when x is 5,833, so here we are on our x-axis, 5,832, my bad, 32. If you were to go up to this line, it would be at a height of 118 for this specific function being evaluated at a specific point. Alright, I hope this helps, and I'll see you guys in our next lesson. Thank you.